For this lesson, we're going to learn how to draw position time graphs. We'll do a couple of practice questions on it. There's a lot more graphing stuff that's coming later, but we need to know the basics before we can do everything else. So on a position time graph, always, time is on the bottom. Any graph that we're using which has time is along the bottom. Time doesn't wait for anyone. Time is a constant, always. Positions, the speed, whatever, acceleration, they're always up in this case. You can find out a lot of things. We can find out the position, we can find out the time it took to get to that position, the displacement at a certain point in time, the distance travelled in a time interval, the direction, so many things. If it's a big slope going up, it'll be positive. If the slope's going down, it'll be negative, and so on. Here's a table, here's a position. You need to figure out how to do a time graph. You cannot just write the numbers 0, 7, 12, 18, 20, that's wrong. Each spacing must be the same. So you need to think, so from 0 up to 20, I have to choose how many numbers. I can skip 2, I can skip 1, but I can write 1, 2, 3, 2, 4, 6, 5, 10, 15, as you like. But because I've got some negatives here on this side, I'm going to put a line through the middle just to make it easy. The line coming up, time will be this way, position will be up here. I'll have my 0 in the middle. So I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That covers everything for the time interval. Going up and down, I can do 5, 10, 15, 5, 10. That's all I need because it doesn't go below that. You can choose your own. This is what we've got here. So next, you just plot your points. So 0 and 14, remember this is my x, this is my y. 0 and 14, so 0 and 14 is about there. 7 sevens, you go along 7, up 7, it's about here. And then you have 12 and 2, you go 12, 2, 14 and 0, and then 18 and minus 4, so 18 minus 4 about here. And then you have your 20 minus 6 is about here. And once you've got the points, that looks very nice line, you draw a straight line through them. You don't join the dots, we're not playing connect the dots. You use a ruler, you draw a straight line to catch as many lines as you can, as many dots as you can. This is my slope. From this slope, we can find lots of things. This is slightly different numbering, but the idea is the same. Here is the slope. What was the position at the beginning of the motion? At the beginning is 0, so the position at the start was 120. There we go, initial position, xi. What was the position at 1.5 seconds? I go along and then I go up to see that it is about 100. What point was it at 60? So 60 here, and what is this? We are here, roughly about here, 4.5. What was the displacement? I can do xf minus xi. I have 3 and 6. So between 3 and 6, these are my 2 points here. 6 and 3. These are my 2 points here. So I will do final minus initial. This will be, where's the final minus initial? 80 minus 40. So, or I should actually say 40 minus 80, right? Because this is final, this is initial. So I will do 40 minus 80. 40 minus 80. My displacement was negative 40. I know it's negative because the slope is going down. So that makes sense. It's a way to check. Finally, if I want to know the distance, same thing. Remember, distance, you can do the final minus initial as well, but you do not need the direction. You do not need to say minus because distance is a scalar, as we mentioned in the first lesson. Was he moving to the left or to the right? If those are my only two options, because the slope is going down, I will say he is moving to the left. It's going towards the negative side. If it was going to the positive side, yes, I would say he is moving to the right. Another thing you must need to do is find a few other things like the slope of the line. That's important. The slope of the line will help you find the speed. So choose 2 points and you do rise over run. I like to start from 0, any point that has 0, and then I will pick another point, which is an easy one, like 10 for example. That's a nice one. So what I would do is draw the rise and the run. I think you may have done this in maths. I'm sure you have. Rise and run, and you can just calculate the slope. Rise over run. this divided by this. So xf minus xi, tf minus ti. Yes? y2 minus y1, x2, x1, that kind of thing. 10 minus 0 divided by, this is 18 minus 8. 10 minus 0 divided by 18 minus 8. 10 over 10 becomes 1. And it's meters per second. Meters divided by seconds. This was meters, this was seconds. Meters per second. That's how we know this must become a speed. Nicely done. Describing the motion, you could say he started from, where can we say he started from? Here, right? He started at minus x and he moved towards the right and he reached the origin at 8 seconds, passed it, continued going away and kept moving. And we can also say the speed was 1 meter every second, so you could say 1 meter per second for this one. You can find the slope of this one in the same place. Choose any 2 points. There is no 0, so I'll pick 2 easy numbers to use. So this is like here, and then we have here, and you can do the same thing. Rise over run. Rise over run. This final minus initial. So what is my final? What is my initial? We didn't do it. Final was 40. Initial was 80. So we'll do 40 minus 80 divided by 6 minus 3. So I can write it here. 40 minus 80 divided by 6 minus 3. 6 minus 3. And you can continue and solve and get your answer. You'll get your answer of 14.3 meters per second. Done. Important point, this rule from your maths lessons. Y equals mx plus b. Sometimes you have c written here. Mx plus b is the same as xf equals vt plus xi. And this we're going to study more later. Thank you.